let's find the inverse of a function defined using a formula. In part B, f of x equals x squared plus 3, where x is greater than or equal to 0. Okay. Can anybody tell me what kind of graph this makes? F of x equals x squared plus 3?
A parabola?
A parabola, yeah. Yep. Now, is a parabola 1-to-1? No. Here's the thing. In order for f inverse to be a well-defined function, f has to be 1-to-1, right? And so from now on, that's all we're going to talk about. If you're asked to find the inverse of a function that's not 1-to-1, you can stop because you're always asked to find the inverse function, not just the inverse. Okay, so now back to this problem. What does a parabola look like? In this case, it's what kind of face? It's a happy face. Is that 1-to-1? Doesn't pass the horizontal line test. So why don't we just stop and give up when you're asked to find the inverse? Okay, you're all right, let's do it. Let's go home. Well, there's this restriction on the domain. X is greater than or equal to 0. So guess where the vertex is x-coordinate wise? Well, actually, what is the vertex? You can tell just by looking at it. It's at 0, 3. So if you make the requirement that x is greater than or equal to 0, you erase this whole left half of the graph because you're only allowed to plug in values greater than 0, which is the value at the vertex. X values greater than input values greater than 0. So you're not allowed to have that left-hand part of the graph. And guess what? Now when you graph it, is it a 1-to-1 function? Yeah. Any horizontal line you draw is only going to go through one point. So it is 1-to-1 under the restriction that x is greater than or equal to 0. So it's not going to be an issue. So let's find the inverse. So you've probably seen this recipe before. So the first step in finding the inverse to a given equation that's a function, a 1-to-1 function, is, well, let's check to make sure it's 1-to-1. Check to see if f is 1-to-1. If it's not, stop. If it's not 1-to-1, stop. You're done. You're not going to find inverses of non-1-to-1 functions because they won't be 1-to-1. And I actually meant to write this underneath the recipe. So let me move that over there. Okay, so step 1 is done. We already checked that. That's the part I moved up here. It passes the horizontal line test. Okay, step 2, you're going to replace f of x with y and get y equals x squared plus 3. Okay, now think about what we did for the last example to find the inverse. What do we do with all the coordinates of all the ordered pairs? We switch them. So symbolically, what we can do then when you're given an equation that represents a function is just switch all the input letter with the output letter, x and y usually. So instead of y equals x squared plus 3, you make the y x, and the thing that was previously x, you make y and get x equals y squared plus 3. Step 4, anybody remember? Solve for y. Because we always want our function in the form the output equals something involving the input, y equals f of x. So, okay, if I want to solve x equals y squared plus 3 for y, what's the first step? Subtract 3. Okay, and that leaves me with what on the left side?
X minus 3 equals y squared.
Y squared. And then square root both sides. Okay. Now, here, can I rewrite it like y squared equals x minus 3 because it's nice to have the output variable y on the left. Then he said square root. What do you usually put in front of a square root? That is true. But we need to decide which one it is. It can't be both. Otherwise, it's not a well-defined function. Because the plus or minus means you have two different formulas. two different outputs for your new y. And you don't want that. So when you take the square root of both sides, initially you do get plus or minus root x minus 3. But think about it. That's two different formulas for y, right? It's not a function if you have two different formulas for y. So which formula is the right formula? Yeah, but you can't count on that always being the case. If I had made the restriction x is less than or equal to 0 originally, so that we had the left half of the parabola, then you would have taken the minus. So what you have to think about is, oh, the domain and range get flip-flopped. The domain and range get flip-flopped. So what was the original domain and range? So go back to this picture that I drew. I didn't draw much of a picture up here, but I drew enough of it. So I drew the right half of our parabola, and I drew the vertex of 0, 3. From that, you can get everything you need as far as the domain and range of f. What's the domain of f? No, well, no, the domain's actually given to you. It's this restriction, right? It's a restricted domain. So the domain is this. That's the domain, D for domain. How would you write that in, say, interval notation? Good. 0 to infinity. Do you include 0?
Yes.
Yeah, because it's greater than or equal to. So there's your domain of your, not of f inverse, of your original function, right? Now look at the picture and see if you can tell me what the range is of f. How high or how low does it get really? The lowest it gets when it opens up, when it's a smiley face, it has a low point, right? And the height of that low point is given by the second coordinate. And that's 3, right? That's the lowest it ever gets. It has a low point when it opens up. So the lowest it ever gets is 3. How high does it get? Look at the picture. Look at the smiley face right here. How high does it get? Goes up forever. So it goes from 3 to infinity. Does it include 3?
Yes.
So you use bracket around any number that's included. You never get to infinity, so you use parentheses around any number that's not included. Okay, so that's the domain and range of f. What's the domain and range of f inverse? So you're going to state your f inverse right here in a second. You're going to, as a final step, you're going to replace y with f inverse of x. That's the notation. F inverse is the name of the function, and then parentheses means of x, right? So, and then before we do that, we can figure out whether or not it's plus or minus by looking at the domain and range of the new function, of the inverse function. So what's the domain of f inverse? All you do is flip-flop them. So what's the domain? 3 to infinity. When I say flip-flop them, these aren't ordered pairs. This is interval notation, right? So you're going to switch. You're going to make the domain of f the range of f inverse, and you're going to make the range of f the domain of f inverse. That's what we mean by flip-flop, right? It's a little bit dangerous because it kind of looks like an ordered pair notation. You're used to flipping ordered pairs around, but that's not at all what that notation is, right? And then what's the range of f inverse? It's the previous domain, so 0 to infinity. Somebody said that, oh, we're going to take the positive root, and that's true, but it's not automatic. Because like I said, if we made a different restriction on the original function's domain, that would change. So how do you know? Well, these are positive values, right? The square root of x minus 3 is positive values. The output, the square root represents the output, right? The formula itself represents the output. Oh, so that's what has to be true. If you left it minus and took the plus away, then you wouldn't have the right range. It wouldn't be positive. That's what this is telling us. The range should be positive. If you stuck a negative out here, it would be wrong. The range wouldn't be positive. It'd be negative, except at 0. So that's how you tell. And I know that sounds complicated. And I know your last class probably didn't discuss that, but the devil's in the details, and we leave those details out on purpose in intermediate algebra, this is where you start thinking about this stuff in this class and more so in calculus to get the right function. But again, I want to say this. Had the restriction been x is less than or equal to 0, then the inverse would have been the opposite of that square root. It would have been the opposite of the square root of x minus 3. That would have been the answer. Okay? Why? Because that would mean if that were the restricted domain, in other words, we look at the left half of the parabola instead of the right half, then that restricted domain is from negative infinity up to 0, right? That's what it changes to. But that becomes the range of f inverse. In other words, the range of f inverse would be negative in that case, which is why you take the negative root.